So for problem 26, the obvious hint is this one, but we have to do a little bit more work here because we don't have a cosine or cosecant half angle formula. What can we do? Some 1 over the sine of 7 pi over 4 divided by 2. So that's going to be 1 over some formula, fill it in, etc. Now the formula for the sine involved a cosine. This is going to be a 1 and then a cosine something over 2. See if you can't finish filling that in. Alright, people are scrambling back, looking back at their notes. Where's that cosine formula? Where's that sine half angle formula? So, in case you're looking for it, here it is. Sine of theta over 2 is plus or minus the square root of 1 minus cosine of theta over 2. So, that one should be memorized, as well as the cosine half angle formula. The tangent is just the ratio of these two, and the 2's in the denominator to cancel out. You have the root of 1 minus cosine of theta over root of 1 plus cosine theta. So that one kind of, you can work around not having that memorized. So there's a minus sign in here. Cosine of 7 pi over 4. Let's take care of something right away here. 7 pi over 8. Can anyone tell me what quadrant that's going to be in? 7 pi over 8. Not 7 pi over 4, but 7 pi over 8. Well, think of it this way. You could also write that as 7/8 pi. 7/8 is less than 1, right? So you're at an angle less than pi, so it has to be in which quadrant? Second quadrant, right? So it's between pi and pi over 2. So it's going to be in the second quadrant. What sign is sine going to have in that quadrant? Positive. So let's get rid of the plus or minus here because it's going to be positive. Let's just say hasta la vista, baby, to those two, and work with this. Seven pi over 4 is in the fourth quadrant, but 7 pi over 8 is in the second quadrant. So overall, we're trying to find the cosecant of 7 pi over 8. That's going to come from the sine here. It should be positive because this angle, the sine of that and the cosecant are going to be positive in the second quadrant. Now, when you evaluate this part, all right, now you got to think about the fourth quadrant. And there, cosine is root 2 over 2. It's going to be positive. You're in the fourth quadrant. You should be getting a little bit comfortable with cleaning up some of this a little bit. So we'll multiply by 2 over 2. That's going to give me 1 over the square root of 2 minus root 2 over 4. That cleans up a little bit more. 1 over the square root of 2 minus root 2 over 2. Yeah, you know, it's just not really crazy about all the fancy arithmetic we have to go through here at the end. really we're taking the reciprocal of this. So let's just flip it up here and write it as 2 over the square root of 2 minus root 2. And that's a nice exact answer. It's not a decimal answer. I don't want decimal answers for these types of problems on the exam. You could rationalize that. You could probably make a fair amount of headway there, but I'm not worried about that part of this. Yeah, let's see. To rationalize this further, you'd multiply by really the conjugate in the denominator. 2 plus square root of 2 over root of 2 plus square root of 2. Now what's that going to give me? It's going to be 2 plus the square root of 2. In the denominator, I'll get 4 minus 2. So, yeah, that gives me square root of 2. 2 square root of 2 plus root 2 over square root of 2. Ugh. Rationalize that again. Multiply by root 2 over root 2. 2 square roots of 2. 2 plus square root of 2 over 2. Those cancel. If I distribute this, then I'll get the square root of 2 square roots of 2 plus 2. Yeah. I don't know. That's a lot of work for not a whole lot of gain. So now you see why I haven't really done too many of those simplifications there. It doesn't get us much. We need to focus more on the trig. So as far as I'm concerned, for a problem like this, try and get here. That'd be good enough. Let's try problem number 80. Sine of 2 times the sine inverse of root 3 over 2. So really what you have here is a disguised version of stuff that we've just been doing. When you have the inverse trig function of something, that's going to give you an angle. Call it theta, call it alpha, whatever your favorite Greek letter is. So essentially this is sine of 2 theta. We have a formula for sine of 2 theta. It's 2 sine of theta times a cosine of theta. Well, what do we know about theta? Theta is the inverse sine of root 3 over 2. Or, flipping things around, how else could I think of this relationship? How else could I rewrite it? Good. Sine of theta is root 3 over 2. Okay. In order to use this formula, I need to figure out what cosine of theta is. There's a lot of different ways you can figure out what cosine of theta is. I think the most direct way is with the Pythagorean Theorem. In fact, a lot of you probably recognize this one right off the bat anyways, right? If sine of theta is root 3 over 2, what's the x-coordinate? Where does that put you on the unit circle? It's 1 over 2. All right, let's do it out in the Pythagorean Theorem anyways. So sine squared of theta plus cosine squared of theta equals 1. But if you recognize it in other ways faster, that's great. I'm not going to make you go through this just to please me. That's root 3 over 4 plus cosine squared of theta equals 1. Subtract 3/4 from both sides. Cosine squared of theta equals 1/4. cosine of theta is going to be the square root of this. Square root of 1/4 is 1/2. Because this is an angle in the first quadrant, we'll choose the positive half. Choose plus. Wow. So we came a long way to figure out that the cosine of theta was 1/2. If I fill that in here, that's 2 times square root of 3/2 times 1/2 gives you root 3/2. Kind of a repeat of the problem that we started this whole thing out with. Just a little bit more window dressing in terms of how we set it up.
That's it.
That's it. Yeah. Okay, so for homework, try 1 through 27. Actually, you know what? Tell you what, let's do 7 through 27 and 79 and 81. So section 3.6 homework, 7 through 27, 79 and 81.